Hi everyone. Today we are going to graph systems of equations and inequalities in two variables. You learn 90% of this in Algebra 1, so it should be a fairly easy lesson. For the first part, it says solve linear systems by graphing. The solution to a system of two linear equations in two variables is the point of intersection. So eventually we're going to solve these algebraically, which is one of my favorite things to do in math. And we're going to be finding the point of intersection of two lines. So a linear equation are two lines. So we're going to find the intersection of two lines. So what we're going to do is graph each equation and we solve for y first if necessary. So this first equation, y is equal to 4x minus 4. I'm going to start at negative 4 on the y-axis and then go up 4 to the right one, up 4 to the right one, and we have that line. Hopefully I can draw a line through there. And I would do these in either different colors or something. I like to do it in different colors so I can see which one, or number them, or do both like I just did. So the second equation, I need to solve for y first. Oops. First mistake coming back. And we start at 7. And go down 3 and to the right 2. Down 3 and to the right 2, and we can keep doing that. And what we're trying to find is the point of intersection of those two lines, because that would be the solution. So the point of intersection is this point here. So the solution is the point, looks like 2, 4. So that means that is the intersection. This point 2, 4 is the solution to the system of equations. So if we have a graph and they intersect, these two lines intersect in one point, there is one solution. If the two lines are parallel, they have no solution because there's no intersection. Because if the intersection is the solution and there's no intersection, then there's no solution. Transitive property. And if they're the same line, that's supposed to say parallel lines. If they are the same line, then that means that there are infinitely many solutions. We can also abbreviate that as IMS. We're in honors class. We don't call that all real numbers. So just make sure that we do not call it all real numbers, because infinitely many solutions mean that there's a solution. This means that there is one number as a solution. This means that it could be a number, or it could be a point, or it could be an order of triple, like we'll learn in a couple days. So unfortunately, I'm at home and my Surface doesn't have the Inspire software, but I typed out the steps for you and I will show this in class when we do this. So to solve the system of equations using the Inspire, the first one is solve for y. That's good. The second one, we need to solve for y. And when you do that, you get y is equal to 2/3 x plus 20 over 9. So what we're going to do is type in the system of equations on the Inspire, solve for y first when necessary. We did that. So on the graph screen, press tab to type the first equation and press enter to graph it. Mrs. Isopi, I believe, taught you how to type in equations. And then press tab to enter the second equation and then press enter to graph it. So you should see the two graphs. One should be blue and one should be red if you have the color one, which I think most of you do. To find the point of intersection, it's going to be very similar to what you did to find the zeros and the min or the max of the functions. If you can't see the window or see the intersection, you have to change the window, which we can always go over. But for our class, I'm just going to have them pop in the window to make it easier. Then you choose menu, 6, analyze graph just like the zeros, and 4, intersect. So the difference between this and what you did with the zeros is you're going to choose 4, intersect. But just like the zeros, the lower bound and the upper bound is going to be asked of you. So the lower bound means to the left of the point of intersection. The upper bound means to the right of the point of intersection. So we graph that and we get I wrote really sloppy. Oh no. Yeah, sorry, I solved it earlier. We get negative 13 and negative 6.48. So graphing this system would have been a pain in the butt because of this y-intercept. We would have had to graph 2 and 2/9 on a coordinate plane and then graphed it and then went up with the slope 2 up to the right 3, and we would have gotten this decimal answer. You could do it. However, if you have technology, it would have been really easy to graph it with technology. Even as a math teacher and doing millions of these probably, if it's a problem like number 1, I'll just graph it real quick. If I don't have graph paper though, I'm a really sloppy grapher. I can't make just graph paper. I would just pick up my Inspire, or I have a TI 83 or 84 lying around. I would just type it in and solve the system of equations that way. So you don't have to use technology. For your quizzes and tests, you are going to have to show work, but you can always, at the end of it, check your solution. So there's 2 different ways we can check it, either by graphing, or if we want to check the solution, let's get blue. We know that x is 2 and y is 4 from that graph. So if we check the solution in my first equation, I substitute x is equal to 2 and y is equal to 4. So in my first equation, I substitute x is 2 and y is 4. So 4 is equal to 4 times 2 minus 4. So again, I put 4 in here and 2 in here. Now I just make sure that each side is equal to each other. And that's a true statement. The second equation, and then again, this is why numbering equations is good too, because you can go back and you can always see, like I checked number 1 here. I checked number 2 here. So we substitute 2 for x and 4 for y. And we get 6 plus 8, which is equal to 14. So that is a solution. So there's 2 different ways that we can check our solutions to these systems. We can graph it in our Inspire, or we can substitute it back into the equation.